So now we're going to derive our final equation for waves. And we're going to do this by solving a little problem. Here's a wave that's moving in this direction. The wavelength is 10 meters. The period is 2 seconds. We'd like to know the speed of the wave. Now, wavelength is just the distance from here to here. That's 10 meters. And it takes 2 seconds for this wave to go by. So how are we going to answer this question? Well, we're going to use a formula that well, first, actually, before we use a formula, we should write down what we know. I know the wavelength is 10 meters, so I'm going to write lambda equals 10 meters. And I know the period is 2 seconds. So I've written this down using the symbols. And I'd like to know what the speed is. So I'm going to write v equals question mark. Now, we don't know of any formula, at least not yet, that links all of these together. But we do know the definition of speed, which is distance over time. That's an equation that we do know. Now, we know that the wavelength is 10 meters and the period is 2 seconds. This is how much time it takes a wave to go by. And this is how long a wave is. So we know when a wave goes by, 10 meters of wave have gone by in a time of 2 seconds. And that's going to give us our speed. Now, let's generalize this. I found the speed by plugging in the wavelength for distance and the period for time. So in general, our formula is v equals wavelength divided by period. Now I'm going to rewrite that in a clever way to simplify this in the way that we're going to see it most often. V equals 1 over the period times the wavelength. Now, let's simplify this a little bit more. What is 1 divided by the period? Oh, isn't that the frequency? And I write v equals f lambda. That is the equation that we're going to use most often in this class. That's the form you're going to see it. So let's summarize about all the equations that we have found. We know that distance equals speed times time. Usually you write this as speed equals distance over time. It's actually the same thing. Frequency is 1 over period, and speed equals frequency times wavelength. Voila! 3 equations. Let's use them. Let's do some practice. Now, our problem-solving strategy for all these is going to be the same. We read the problem. Then we write down everything you know with symbols. So write down things like, lambda equals 5 meters for wavelength equals 5 meters, and so on. By doing this, you are putting down what is important and rejecting all the unimportant stuff. Then you're going to write down what you want. You're going to write down the symbol for what you want. Now you've got all the symbols and all the numbers. You are ready to pick an equation. So you're going to write down that equation. You're not going to be plugging numbers in. You're just going to write down the equation. Then your last step, you plug in your numbers and you solve. And that's where all the math comes in. It's this last step. So let's do a couple. I have 3 questions right here. You can pause the video now and try to work them out. And I'm going to give the answers. Number 1. Wave travels 25 meters in 3.4 seconds. What's the speed of the wave? Well, let's write down what I know for number 1. I know the distance the wave travels is 25 meters. And I know the time that it takes is 3.4 seconds. Speed of the wave. I want to know speed. So I made a nice little list of 2 columns, what I know, what I want. I want the symbol V for speed. Is there an equation that relates these? Yes, there is. It looks like this. Speed equals distance over time. And I just plug in 25 divided by 3.4, and I will get 7.35 meters per second. Gotcha. Okay, let's do number 2. Pause the video here if you want a chance to work it out yourself. Number 2, period of a wave is 0.33 seconds, so I know period equals 0.33 seconds. T is the symbol for period, the units are S for seconds, and I want to know the frequency of the wave, so I want F for frequency. Is there an equation that relates F and T? Absolutely. F is 1 divided by the period, and if you plug 0.33 in here, 1 over 0.33, that'll give you approximately 3. And what's the unit for frequency? Oh, it always hurts if you forget it. It's hertz. Okay, now pause the video. Try your hand at number 3. A wave travels with a speed of 20 meters per second. So I'm given the speed, which is 20 meters per second. I'm given the frequency, which is 7 hertz. I want the wavelength, and the symbol for that is this upside down y, which is lambda. All right, is there an equation that relates these? Absolutely. It's V equals F lambda. We plug in the numbers. 20 equals 7 times lambda. Now we just solve for our known. This is the same thing as 20 equals 7x. And that's just a math problem. Solve for x, solve for lambda, and you will get 2.86 meters. If you just do the algebra and do the math. Great. Now, let's do a little harder problem. This is more of a challenging question. This is more like something you get on a full-on test. So let's take it and use our problem-solving strategy. Number 1, what pieces of information? Oh, let's read the problem. You make waves in a slinky. You make 3 waves every second. The waves travel a distance of 14 meters in 2 seconds. What information are you given? Oh, what a great question. That's what we had to put down anyway. 3 waves every second. What is that? 3 waves per every second. Waves per second. Oh, that's frequency. 3 hertz. The waves travel a distance of 14 meters in 2 seconds. So I know that distance is 14 meters. And I know that the time is 2 seconds. Now, I'm not going to put speed or period here. I know that period is also time, but this doesn't tell us that the period of the wave is 2 seconds. It just says they travel a distance of 14 meters in 2 seconds. So they've just given us a time, right, and a distance. That might be helpful. Calculate the frequency. Hey, this is nice. Do we need to do any work? Not really. We already know the frequency. It's 3 hertz. Go us. Number 3, calculate the speed. Now, we're not given the speed, so this is a little harder than number 2, but I think we know this equation, V equals distance divided by time, or I should note we want to find V. Let's put that down. We want V. V equals distance over time. That's 14 seconds, 14 meters over 2 seconds, 7 meters per second. Next up, calculate the period. Feel free to, of course, pause anytime because you should be doing this yourself. Calculate the period. Well, we don't know the period, but we do know the frequency, and period or frequency are related by period is 1 over the frequency. So this is 1 over 3 seconds, a third of a second. All right, now for the last question, calculate the wavelength. So we want to find lambda. Well, let's pick an equation. We know that v equals f lambda. Do we know what v is? Let's see, v is the symbol for speed, and yes, we do. We do know that one. That's 7. Do we know what the frequency is? F for frequency? Yes, we do. In fact, it was given in the problem. It's 3 hertz. And do we know what lambda is? No, we don't. That's the thing we're trying to find. Can we solve this equation? Absolutely. We divide both sides by 3. So we get lambda is 7/3. It's about 2.33 meters. Okay, we're ready for the last question. What is the medium? Do we have an equation for that? No. So how do we solve this one? Wait, what is the medium? It's the thing that does the waving. Are we told what's doing the waving? I didn't write that down in my little list of things I knew. Let's go back and read the question. You make waves in a slinky. So what's waving? It's the slinky. Now it's not you. You are the cause of the waves, but the medium, the thing that's actually doing the waving itself, that's bobbing around, is in fact the slinky. And that is the medium. All right, good luck.